All right, I'm going through the last minute AP Calc review part 2. We did 1 and 2 on previous videos. This video I'll do number 3. So we have a graph pictured of F, and the graph consists of 5 line segments and 1 semicircle. So we see our line segments here, we see the semicircle. Part A, well, let's see here. The function h is defined as a definite integral of f of t plus 2 dt. So part A says find f of 3.5. So f of 3.5, we're just looking for our f graph, order pair on the f graph. So f of 3.5 is this point here. So that's just going to be equal to 1. 3.51, yeah, okay, so just 1 right here. For part, and then next part, f prime of 3.5, that's asking for the slope of the f graph at 3.5. So we're not looking at the order pair now, we're looking at the slope. So the slope of this line segment is positive slope up 2 over 1, so there's my slope. Okay. Or we can choose two order pairs here, 4, 2, and 3, 0, and do change in y over change in x, and we get 2 over 1, which is 2. Okay, part B, find h of negative 2, h prime of negative 2, and h double prime of negative 2. So that requires us to have to first find our h prime and h double prime formula or equation. So to find h prime, well, let's, all right, I'll just go down the list of steps that I took for each term. So h of x is already found for us, so we can go ahead and move into finding h of negative 2. So h of negative 2 is, we just replace the x with negative 2. So the integral from negative 2 to 2, sorry, negative 2 to negative 2, there's no change in t value, so that means there's no area for us to find. It's always going to be 0. Okay. Before we can move on to h prime of negative 2, we first have to find h prime of x. So h prime of x requires us to find the derivative of this expression. So the derivative of the definite integral, we know derivative and integrals are going to cancel each other out. We're just left with what's inside, so f of t plus 2, or f of x plus 2. Plug the upper bound variable into the expression's variable. F of x plus 2, so if we want to find h prime of negative 2, we just plug replace x with negative 2, so we get f of negative 2. So if we look at our graph, f of negative 2, it's just going to be negative 1. So we get negative 1 plus 2, which is 1. All right, next up, h double prime of negative 2. So to find h double prime of negative 2, we first have to find h double prime of x. H double prime of x is just taking our h prime expression and finding the derivative. So f becomes f prime, 2 goes to 0. So now we have f prime representing the formula for h double prime of x. So then when we do h double prime of negative 2, that's equal to f prime of negative 2. So we're asking, what is the slope of the f graph at negative 2? The slope of the f graph at negative 2, we see that is a sharp turn. So there's no slope. Slope is undefined. Okay. For part C, okay, find h of 5. So to find h of 5, we have to use this formula. So plug 5 in for x. Now when we plug 5 in for x, we get definite integral from negative 2 to 5. And it's easier if we split this up into separate terms, just so that we can divide this into easier problems. So now we can do definite integral from negative 2 to 5. That we can read the graph. And then definite integral from negative 2 to 5 of 2 dt, we can go through power rule separately. So this we can use the graph, and this is a standalone problem that we can do power rule with. So looking at the graph from negative 2 to 5, negative 2 all the way to 5. So we need to find the area of these regions. This is 1/2 base times height, but it's below the x-axis, so we can make that a negative 1/2. Semicircle is pi over 2 r squared. The radius is 2, so pi over 2 times 2 squared. That's 4 over 2 pi, which is 2 pi. And then here, 1/2 base times height, 1/2 2 times 2, which is 2. So we total those together, we get negative 1/2 plus 2 pi plus 2, and then the result of this definite integral, the integral of 2 becomes 2t, right? We do power rule. Any constant is going to go up one level to linear, and then we have our bounds ready to now plug in. Plug 5 in for t, minus, then evaluate the lower bound. So we get 10 plus 4, which is 14. So we total this together, we get h of 5 equals 15.5 plus 2 pi. All right, part E. Part D, write an equation of the tangent line at x equals -2. So tangent line equation requires order pair and slope. So order pair is -2, 0. Okay, we see that on the graph here. I'm sorry, -2, 0. Here, we have that information from part B. And then the slope, h prime of -2. Okay, h prime of -2, we found that from part B as well, that's +1. So we have our ordered pair, we have our slope, and then we do point slope form, okay, and that's part D. On what interval is our function h increasing? So we're going to keep in mind that really we're looking at the derivative graph for h with this f function. So our function is increasing wherever it's above the x-axis, so all these are positive slopes, positive slope, positive slope, and then anything that lands on the x-axis is going to be your where the original slope is 0, and anything below is going to be negative slope. So we have mostly positive slopes except for this region, which is negative slope. Okay. So critical points at -3, -1, and 3. Above the x-axis, below the x-axis, above and above. So our function is increasing in these 3 intervals because h prime is greater than 0. For part F, on what interval is our function concave up? So concave up, if we're looking at the derivative graph, the first derivative graph, we know we can pick out critical points by looking at the peaks and valleys. So peaks and valleys will be your points of inflection. And then the slope of the f prime was going to translate to where your original graph is going to be concave up or concave down. So negative slope translates to concave down, positive slope, concave up, negative slope, concave down, positive slope, concave up, negative slope, concave down. So we create our concavity sign line, and then we can find our, we see we have 4 points of inflection, but it's asking for a concave down, so concave down in 3 intervals from concave up in 2 intervals from -2 to 1 here, and then also from 3 to 4.